Okay, I'm going to go through a pretty tough looking example for the factor fully type question, using the factor theorem, finding the factors, and getting down to the final answer. And the couple of questions you did were not quite this tough, I don't think, just number wise, but you should be able to follow the exact same pattern. So the question says factor fully the following expression. We've talked before, we basically need to look at all the possible factors. The factors are determined by taking the factors of this last number as possible numerators and the factors of the first number as possible denominators. That wasn't very straight. So on top I've got 1 and 270, 2 and 135, 3 and 90, and of course I did it again but forgot to put in, we have plus or minus in both cases. And so there are a lot of different possibilities here. I didn't list them all, obviously. What I need to do is basically find one. And my suggestion had been start with the easiest ones. So basically, test P is 1, it doesn't work. Test P is -1, it doesn't work. Test P is 2, it doesn't work. Test P is -2. Oh, look at that, it does work. Now, at this point, I'm just going to mention quickly, you want to recognize homework questions that you have to do and exam questions that you have to do are quite different. My assumption is if I assigned a question like this, you would have plenty of time to try different things. You'd have other sources that you could look at. What did I just do there? That was weird. Other sources you can go to and sort of figure things out, where on an exam, obviously, I'm looking to know, do you know how to do the question? Not necessarily trying to challenge everybody so much as just verify that you know what you're doing. So if you needed to in a question like this, where there's this many possibilities, one possibility is just kind of go to something else, an external source of some sort. I don't know how well you see this. But essentially what I did was I just made a little Excel graph, not even graph, Excel table. In here I put a formula for times a1 to the exponent 4 plus 7 times a1 to the exponent 3 and so on. Obviously the equation that we had up here. And I just typed in -4, -3, and then of course, stuck right now. If you drag that down, it'll just run through those numbers. So I'm testing numbers here that I don't necessarily even know are possibilities, although I think all of these ones are. But right off the bat, I see pretty quickly, -2 and +3 are two of the numbers that would work for me. So I use the -2, go through the problem, synthetic division, and I know the answer should be working out. So as I go through it, drop down the 4, 2 times -4 is -8, add those together, -1, -2 times -1, +2, and I'll just say and so on at that point. You can do the math to verify that it works out. And of course, the big key is at the end here, I should be getting a 0. So my remainder on the end here is 0. What that tells me, kill this now, is that x plus 2 is definitely one factor. We kind of knew that already. When the -2 works, then the x minus -2 or x plus 2 is the factor. And what I need to do though is go further. I have 4x cubed minus 1x squared minus 78x plus 135 still to continue with, to factor fully as the question asked. So basically then I'm just doing the same question again with this number. I saw from my Excel sheet that 3 works. And so same sort of thing, a new synthetic division as if this were my original question. And I've got my drop down 4, multiply to get 12, add them together to get 11, multiply to get 33, add them together to get -45, and then multiply, you get 135, and again, the 0 on the end is the remainder. So x minus 3 now. again, the opposite, the number that, or the term that goes to 0 when this is used. And I still have to factor further with the 4x squared plus 11x minus 45. So if the question says, get down to this point, do the synthetic divisions and long divisions as much as you need to, then you might be done. I don't expect questions should ever say that, but based on a question I got from, an email I got, it sounded like one of the questions might have been worded that way. To factor fully, I do have to go that extra step and factor this using one of the methods that we would have learned in the past. Excuse me. That means I need to find two numbers that multiply to the same value as this 4 times this, excuse me, negative 45, which is negative 180. And they have to add to the middle term the positive 11. And so the two numbers are positive 20 and negative 9. And then we go and I did this by decomposition. If you are more comfortable using a slightly different method, that is fine. This is the one that I find most people can do, especially good math students. Where the other one, sometimes people sort of don't follow it because there's a little bit of guess and check. So if you use something else, fantastic. If not, then straightforward. Find the two numbers that multiply and add. Split the middle term into two parts, 20x minus the 9x, the two numbers that we had here, obviously. Do a common factoring between these two values and the other two values. So treat the first two terms as if they're one thing, treat the next two terms as if they're one thing. 4x is the common factor here, negative 9 is the common factor here, and then technically the brackets become a common factor, and I pull them out front, just kind of the way I show the grade 9s and 10s, because it's nice to be able to always pull the common factors out. And so my final answer is the original expression, factors to x plus 2 from the first slide, x minus 3 from the second, and these last two terms right here. So that's basically a full question. There was, somebody asked me a question about some of the tougher ones, 9 and 10 specifically. Take a quick peek at them. Obviously those types of questions are tougher for a reason, but I can maybe give you a quick hint. When I look at them, they're actually pretty similar if I remember. The polynomial 12x cubed plus kx squared minus x minus 6 has 2x minus 1 as one of its factors. Sorry. What that means basically to me is that if I divide 2x cubed plus kx squared minus x minus 6 by that value, I get an answer of 0. It also means, if we think about the factor theorem, when I put the value that makes this 0, so if 2x minus 1 is 0, then x would have to be 1/2. When I put 1/2 into this thing for x, sorry, I'm not having a lot of luck highlighting here. If I put 1/2 into this part of the expression, into the actual polynomial, I'll get an answer of 0. So 12 times 1/2 to the cubed plus k times 1/2 squared minus 1/2 minus 6 equals 0 ends up being an equation, and we can solve it. 10 would be similar. Sorry, that wasn't the best explanation I know, but I am running super late, so I'm going to save it there, upload it, and hopefully at least the first part will get you through. If you have trouble with the tougher questions, it's not always a big deal. Obviously, we can take them up a little bit further on, and I can give you some solutions to those as well. All right, and have a good day.